We're here at Travis Air Force Base Museum in Fairfield, California, and the end result of a tremendous restoration effort is behind me, the B-29 named Miss America 62. We're going to take an in-depth look at the airplane, both inside and outside, and talk about some of the features and the various crew positions in the airplane. The B-29 is equipped with 4 Wright R3350 piston engines. They are 18 cylinders. It carries a 4-bladed prop on each engine, and the prop diameter measures 16 feet. There are 4 engines on the B-29. The B-29 has a wingspan of 110 feet, and the fuselage measures 99 feet long. The horizontal stabilizer, or vertical tail, stands 27 feet from the ground to the top of the vertical stabilizer. Here we see the right side of the flight deck where the pilot station is, just inside this window here. And behind him, at this window, is the flight engineer station. The flight engineer sat facing to the rear and facing his control panel, instrument panels and controls on a table-like surface there at his station. This window here, I don't know whether you can see my name, but just above my name, the window there, that's where my position was. You also see the name of the flight engineer, FN Mount, Nick Mount. His name is also Nick. The nickname we call him Nick is below his window back here. Here in the nose of the airplane is the bombardier's position. Right in the very front of his position, in the very nose of the airplane, is the northern bomb sight, which he uses to make the bomb run and aim his drop. When we own the bomb run, the northern bomb sight locks into the autopilot, and he is actually controlling the direction of the airplane through the adjustments made in his bomb sight as we make the bomb run, and he's aiming at the target of the bomb sight. And directly behind his position are the 2 pilots' positions. Now, these bombs painted on the plane each represents a bombing mission that the plane flew. There's several more missions on the plane than our crew actually flew, but the airplane was flown by some other crews during the time that we were brought back to the States for lead crew school. The round figures above the bombs, those represent mines. We did some mining of the inland sea with this airplane, where we dropped mines that were both magnetic and sonic. They were dropped with little parachutes attached to them into the inland sea. The strategy there was to immobilize the Japanese shipping in the inland sea, which was their main means of transporting goods and materials from one point to another in the Japanese Empire. The railroad system, the highway system, was not nearly adequate to handle all of the traffic, so the inland sea was really the highway and the strategy was to immobilize that capability by mining the inland sea. The two Jap flags represent two Jap fighters that were confirmed kills by our gunners. They shot down two Jap fighters confirmed as kills because they were actually seen to crash into the water on land, and definitely were kills. So that's what the two Jap flags represent. Here we have the window beside the navigator's station. It's right to his left as he sits at his table. And then directly above that, on top of the fuselage, is the upper forward turret. This turret has four 50 caliber machine guns mounted in it. To the rear of the turret is the navigator's dome. It sits right atop the fuselage, and it is for the purpose of allowing the navigator to make celestial shots with his sextant to plot positions of the airplane when it's when it's on a flight using navigation. He might take sun shots. He might take other celestial shots on certain stars, and with charts that he has, he can take 2 or 3 shots and plot those, and where those lines cross, that's the location of the airplane. That's what's known as celestial navigation, and this dome is to allow him to make those shots while the airplane is in flight using his sextant.
Go.
This is the left main landing gear. The plane is equipped with hydraulic brakes and the mechanism to extend and retract the landing gear is driven by hydraulic pressure. This is the left outboard engine that you're looking at now, and you'll notice the name June on this, painted on the side of the engine nacelle. That, I think, is the name of either the wife or the girlfriend of the ground crew person that was assigned to maintain this engine. You'll also notice other positions on the airplane where there is a name of the crew member and his wife or girlfriend if he's not married. For example, on the left blister gunner position, below the blister, you see the names Evelyn and Dick. Well, Dick Bush was the left blister gunner, and Evelyn was his girlfriend at that time. Dick was not married, and that was his girlfriend at the time he was serving during World War II. You'll see those around all over the airplane at various crew member positions. On the left side of the airplane, on the left side of the fuselage, about halfway between the nose and the tail, and on the very top of the fuselage is a dome or bubble that is above the central fire control gunner station. The central fire control gunner, when he's in his position, is on an elevated seat, and his head goes up into this dome, enabling him to have 360 range of view in all directions around the airplane. And he directs the fire of the gunners, the guns, and which gunners are going to have control of which guns, because he has a complete view of all the area around the airplane and can see a fighter attack coming from any direction. Behind the CFC, the Central Fire Control Gunner's Dome, is the upper rear turret itself with two 50 caliber guns mounted in it. This is the left gunner's position. Dick Bush was the crewman assigned to this position, and he sat just on the other side of that gun sight, and this was his gun sight to control whichever gun was assigned to him, aim and fire using that gun sight. The vertical stabilizer, as we mentioned, measures 27 feet from the ground up to the top of the vertical stabilizer. The circle R insignia is a designation which can be easily seen from a distance to identify the wing and the group that the airplane is assigned to. In this particular case, the circle indicated our wing designation, which was the 313th Very Heavy Bombardment Wing. And any B-29 we saw with a circle on the vertical stabilizer, we knew was assigned to the 313th wing. The letter R inside the circle designates the group that the airplane is assigned to, and in this case it was the R designates the 6th bombardment group, which is the group we were in and the group, of course, that our plane is assigned to. The skid that you see extending from the bottom of the fuselage downward toward the ground, that's a tail skid. It's there to protect the fuselage in the event that a landing is made tail low, and it's to prevent the fuselage itself from scraping on the runway. Normally, of course, a proper landing, you would not come close to causing this skid to make contact with the runway, but it could happen, and that's what it's there for, to protect the fuselage. The skid retracts simultaneously with the landing gear. When the landing gear, that is the main gear and the nose gear, retract, that skid retracts too, and it makes a smooth surface on the exterior of the underside of the airplane. Trailing edge of the main wing from the fuselage out about 2/3 distance, or just beyond the outboard engine, is the flaps for the airplane. The flaps are used to increase the lift of the wing at a slower airspeed, and they are used both in the takeoff and the landing operation of the airplane. Extend from the fuselage outward to about 10 feet outboard of the outboard engine, and then from that point on to the end of the wing is the aileron surface, which controls the banking of the airplane. The same configuration is on the right wing as well, of course. We're looking at the lower rear gun turret. There are 4 gun turrets on the airplane. There's the upper and lower rear and the upper and lower forward turrets. The turrets have 50 caliber machine guns in them. The upper forward turret has 4 50 caliber machine guns in it. The other 3 turrets, the lower forward, the upper and lower rear, have 2 50 caliber machine guns mounted in them. The turrets can rotate 360 degrees. They can be controlled from any one of the gunnery positions except the tail gunner position. The control of the turrets are assigned by the central fire control gunner, who sits on a pedestal seat with his head up in a dome bubble and has full view 360 degrees all around the airplane. He can switch control of any of the 4 turrets to any of the gunners that have a gunnery sighting station. That would be himself, the right ballistic gunner, the left ballistic gunner, and the bombardier in the nose. The last guns are the tail guns, which are 2 50 caliber machine guns mounted in the tail. And the tail gunner section is right in the tail of the airplane. This is a tail turret. The tail gunner sits in that compartment above the fuselage, sitting on top of the fuselage more or less. The tail turret contains 2 50 caliber guns, and it's fired by the tail gunner only. It cannot be assigned or switched to any of the other gunners, but it's fired only by the tail gunner and from his position. They're 50 caliber guns. This small wing back here is called the horizontal stabilizer. It has it is the control surface that determines the climb or the descent of the airplane. In other words, as you pull the yoke back, this control surface will cause the plane to climb. If you push the yoke forward, it causes the plane to nose down and descend. The vertical surface here is called a vertical stabilizer. That control surface determines the yaw of the airplane, the movement of the nose of the airplane from right to left on a horizontal plane. That's controlled by the rudder pedals. That's the rudder. The vertical stabilizer has the rudder, the movable control surface at the rear of the vertical stabilizer is called the rudder, and that is controlled by the rudder pedals at the pilot station. You're looking at the nose wheel of the airplane. This airplane has what's called a tricycle landing gear, the main gear and the nose gear. This is the nose wheel, and it, of course, retracts simultaneously with the retraction or extension of the main gear. It has hydraulic brakes, as does the main gear. This landing gear, this nose gear, is raised and lowered by this hydraulic cylinder here, and when it is brought up, this arm goes parallel to the floor, and the wheel comes back this way and goes up in this area here. It locks right here in this arm. The brake right here locks right in here where that hinge area is. And then, of course, when this engages here, it brings the doors shut, closes the doors behind the wheel retraction. Above us here is the entrance hatch to the flight deck. You use a ladder to climb up, and that hatch raises up and allows entrance to the front section of the airplane, to the flight deck. Those crew members who would enter the airplane through this entrance are the bombardier, the two pilots, the flight engineer, the navigator, and the radio operator. Those are the crew members that function. Their stations are located in the front pressurized section of the airplane. And now we will go up into the front pressurized section of the airplane and look at each of those positions in detail. This is the pilot's flight deck. There's two sets of controls, one for each pilot. You have the yoke, which controls the elevators, which makes the plane climb or dive. And you have the ailerons, which are the wing in the wings. That when you turn the wheel, it makes the plane bank left or right. To pull the yoke back or down, pull it back makes the plane go up, push it forward makes the plane go down. The pedals are for the rudder, your vertical tail section, the rudder, and that coordinates with the ailerons to make what's called a coordinated turn. So the plane doesn't feel like it's skidding one way or the other. Here you have your throttles, the 4 throttles, one for each engine. You have your trim tab, which is a little section of the control surfaces, and rather than having to hold pressure against that control surface all the time, you set the trim tab and it causes the little trim tab to hold the pressure. Makes flying the plane easier. The pedestal here, you have some of the engine control switches and knobs. These 4 knobs here, one for each engine, that's to feather the engine. That means to turn the propeller so that it cuts the wind rather than windmills or spins. And when an engine is disabled, some malfunction, you want to feather it so as not to damage the engine. So that's what these 4 buttons are. Then you have the automatic pilot controls here. The plane has an automatic pilot. You can set it up and fly it by automatic pilot. On your control panel, you have all your flight instruments, and you have some few engine instruments. Most of the engine instruments are behind me here on the flight engineer's panel. The flight engineer is in the technical aspect of the airplane, the engines and other systems of the aircraft. He doesn't know a whole lot about the armament, that is the gunnery system and the bomb system. The bombardier and the central fire control gunner are schooled in the armament and bombing system. Board here, instrument panel. You have the flight instruments. You have your artificial horizon, your turn and bank indicator. You have your compass. You have your altimeter. Your flap indicator indicates whether you have any flap down. Flaps are an extension of the wing surface, and they're used in takeoff and landings, and this indicates the degree of flaps that are extended, if any. In normal flight, your flaps are retracted. You have no degree of flaps extended. These 4 lights here, one for each engine, is the propeller pitch limit. If your propeller is spinning faster than it should, this light will indicate that. These lights indicate the position of the landing gear. If it's down and locked, the lights will will tell you that. Flight instruments, you have your miles per hour in that needle goes around and keeps the big needle goes around, the little needle gives the thousands, and then you have your turning bank indicator, which is this, we call it needle ball instrument. It shows whether the plane's banking right or left. And then on the right hand side you have your rate of climb indicator, indicating your rate of climb or your rate of descent, measured in thousands of feet per minute. Those are additional flight instruments. You're looking at the Northern bomb site here, which is was a highly secretive piece of equipment during the war. It was the best bomb site in existence, and the United States military was the only military organization that had this bomb site. Also, you have a gun sighting station here for the bombardier. He also, in addition to being the bombardier, he was also a gunner. He could fire these turrets from his remote gunnery station, just like the gunners themselves. But he sat, that was his position, down in the nose. His seat was that. He could see more. He's sitting out there more or less in space. In the nose of the airplane.
Okay, and this seat over here?
That's a pilot seat. The airplane commander normally flew in that seat. The pilot flew in this seat. I have flown both places, but I flew here in this right seat most of the time. And the airplane commander, Bruce Alger, would fly in that seat. After Bruce left, was sent back to the States, I took over the airplane commander of the crew, and when I flew, I would fly in that seat. And steel armor plate behind me here, and on the other side of it is the flight engineer's position. And as I said earlier, the flight engineer was the technical person on the crew. He was trained in maintenance and operation of most all the systems of the aircraft, except he was not expert in the gunnery. The CFC gunner, Central Fire Control gunner, was the expert on the crew on the gunnery system, and on the bombing system and the bomb site, the bombardier was the expert on the crew on that system. But the flight engineer was trained in the engines and other mechanical systems of the aircraft, and it was his job to monitor all the engine functions. That's what all those different dials and meters on his instrument panel back there do. They tell him what's going on with each of the engines at all times. He also maintained what was called cruise control, meaning that it was his job to maintain statistics on fuel consumption, power settings, RPM of the engines, so as to maximize the fuel usage to the greatest benefit for range. It was always a problem with us on just about every mission to make certain that we had enough fuel to get back to base. We were flying the airplane at in a range, a distance that was far in excess of what it was really designed to do. And so fuel consumption was always a critical thing, and the flight engineer maintained the records, the cruise control, which was the fuel consumption charts, and told us what power settings and what engine RPMs were the most fuel efficient. That was one of his very important functions, as well as to monitor the performance of each engine from the instruments that he had there, to make sure that the instruments were operating properly, such as cylinder head temperatures being within acceptable limits, RPMs and manifold pressure on each engine being within acceptable limits, and so forth.
All right, this is the this is engineer position, navigator.
Oh, this is the engineer.
Engineer.
If you're
okay.
photographing this,
Right.
This is the flight engineer.
Okay.
The navigator's position, his table here, his chair. He had a lot of charts to work with, so he had a table to use to work on. Also above him and to the rear of the turret is a dome which he used to take celestial shots. That is, he used a sextant and took angle shots on heavenly bodies, the sun, the moon, various stars, in order to plot our position at any given time. And that's a position where he worked at this table. He also has a device in the floor behind this turret, which is called a drift meter, and that enabled him to take drift readings to determine wind direction and velocity. And he would take these drift readings on any object below the airplane. In our case, mostly it was water. So he would take drift readings on whitecaps, the wave whitecaps. If he were over land, he'd take drift readings on some object on the ground, such as a bridge or a factory building or whatever he could pick to sight on. But that told him, the drift readings told him the wind direction and velocity. This is the radio operator's position, and he has several different radio systems with which he is quite familiar, and both in the maintenance and the operation of it. And he fills a very important position in keeping communication between the aircraft and the base, or the aircraft and surface vessels, ships, or other installations, other aircraft. He had a very important job in the communications area, and this is where he worked. The B-29 has two bomb bays, a forward bomb bay and a rear bomb bay. Each has a separate set of doors. The forward bomb bay door starts here and runs back to here. And the doors, there's two sets, there's two doors with the opening in the middle, the division in the middle, and they come down like so. Do you see my hand?
Mm-hmm.
The rear bomb bay starts here and goes back to here. Both bomb bays are the same size, and with a full bomb load, they're capable of carrying 10,000 pounds of bombs in each bay. So for a total of 20,000 pound bomb load for the airplane. The B-29 has three pressurized sections, including counting the tail section. The forward pressurized section, which is from the forward bomb bay bulkhead out to the nose of the airplane. And in that section is housed the station of the bombardier, the two pilots, the flight engineer, the navigator, and the radio operator. And then aft, behind the rear bomb bay, is a bulkhead, and the center pressurized section starts and runs back to include the gunner's section and the radar operator section. Between these two pressurized sections, the forward pressurized section and the center pressurized section, there is a tunnel which is also pressurized and runs over the bomb bays so as to allow a crawl-through passage from the forward section to the center section without having to depressurize the airplane. We could move from forward to rear or vice versa without depressurizing the airplane. And the third pressurized section is the tail gunner's section at the very rear of the fuselage of the airplane. This is the radar dome. The radar operator station is above and to the rear of the rear bomb bay, to the rear of the gunner's section. He has all of his controls and his scope and so forth back there on a table at his station. But this is the radar dome that we're looking at here. We're now on the right side of the airplane, 2/3 or more toward the rear, toward the tail. This is the rear door. It opens into an unpressurized section of the airplane. This entrance would be the entrance that is used by all three of the gunners, the CFC gunner, the right blister gunner, and the left blister gunner, as well as the tail gunner and the radar operator. The radar operator's station is just forward of a bulkhead that's right here in the pressurized section of the plane, just behind the gunner's section. We'll be going in through this doorway into the rear pressurized section of the plane and see all of this area back here, the unpressurized section, as well as the tail gunner section shortly. Really what you might call the gunnery section, since 3 of the 4 gunners on the crew are stationed in this section here. The pedestal seat, which raises and lowers with a hydraulic mechanism is the station of the CFC gunner, the Central Fire Control Gunner. He is the chief gunner. He is in charge of the gunnery crew, and his responsibility is to see that the gunnery system is working properly before every mission, and also to direct the firepower of the four turrets, the upper, forward, and rear, and the lower forward and rear turrets. He can switch control of any or all of these turrets to whichever gunner most appropriately can use them, depending on what direction the fighter attack is coming from. He can switch the guns around as needed. He also has a sighting station and can fire any of the four turrets from his position. In the right blister gunner's position, and have my hand on the gun sight, the remote control gun control mechanism that the right blister gunner uses. From this position, he can aim and fire any one of the four turrets, upper and lower forward, upper and lower rear turrets. Across from me, on the opposite side of the airplane, is the left blister gunner's position, and functions in the same manner as I have described for the right blister gunner. He can control any one of the four turrets and fire any one of the four turrets from his position. The gunner has full control of all four turrets in that he can switch control of any one or all of them to any one of the gunners, or fire any one of the turrets himself. He has complete view, 360 degrees of the airspace all around the airplane. This hole in the bulkhead that I'm pointing to here is the tunnel. The tunnel is a connecting path between this gunnery section and the forward section of the airplane, where the radio operator, navigator, pilots, and bombardier are housed. The tunnel enables any crew member to move from the forward section to this mid section of the airplane while the cabin is pressurized without having to depressurize, since the tunnel is pressurized just as is the other sections of the airplane, the nose section and the midsection of the airplane. We call it the tunnel. We crawl through it on our hands and knees to get from the forward to the midsection, or vice versa. It spans or goes over the two bomb bays. The bulkhead here is a bulkhead into the rear bomb bay. It's an access door into the rear bomb bay. And at the other end of the forward bomb bay, the forward end of the forward bomb bay, there is a similar bulkhead, which is an access from the forward pressurized section into the forward bomb bay. The plane has two bomb bays, as you might have guessed by now, and these are access doors into the respective bomb bay areas. They are sealed when the cabins are pressurized, and they are airtight, enabling the crew to pressurize the cabin of the plane. I am sitting in the hatch or the doorway of the rear bulkhead, the wall or partition that seals off the pressurized, the middle pressurized area of the plane from the unpressurized section that we actually are in. Just inside this bulkhead is a table and equipment on the wall. This is the radar operator station. He operates the radar equipment, airborne radar equipment that the airplane is fitted with. And he works with the navigator in navigational, furnishing navigational data to the navigator that he is able to determine using radar fixes on certain objects on the water surface or on the land surface. He also works with the bombardier on the bomb run when there is cloud cover below the airplane and therefore there is no visual contact of the target, and he and the bombardier work together using radar to actually do the aiming, the identification of the target and the aiming for the bomb run. So he has a very important function both in the area of navigation and in the area of the actual bomb run and bombing operation. The radar operator can also double as a gunner. Supposing that you had one of your gunners disabled, maybe got hit with flak or was hurt and unable to function, the radar operator is trained in gunnery and can substitute for a disabled gunner. This section that we're in is the unpressurized section of the airplane. It's never pressurized when the other compartments of the airplane are pressurized. It houses what we call the putt-putt, which is a gasoline-driven generator and is an auxiliary electrical power source if the generators driven by the engines were to become disabled or inadequate. It's a gasoline-driven generator that we call the putt-putt. Behind it is a dome that's recessed toward the underside of the airplane, and this is a radar dome. That's radar equipment, and that's a radar dome that it's housed in, extending or protruding underneath the belly of the airplane. And moving on back from there is a bulkhead. After you travel through some more unpressurized section, is a bulkhead that seals the tail gunner's section so that it can be pressurized. The tail gunner's section has two 50 caliber machine guns pointing toward the rear and has lateral travel of about 25 or 30 degrees in each direction, right and left, from center straight line of the aircraft fuselage. It's twin 50 caliber guns that are manned, fired by the tail gunner. His section is pressurized. When he goes into his section, we depressurize. He moves from the center section with the other gunners where he normally rides, but when we take battle positions, we depressurize. He moves back to his tail gunner position, seals the bulkhead door, and then we repressurize the cabins that are pressurized, and with him in his position there.